Hello and welcome back to Human Resource Machine. Looks like recording is fine now. So 37, if you want to know the exact reason, go to the beginning of where we played 36 and we'll have an explanation for you there. 37, scavenger chain, year 37. Each pair on the floor contains one data and two, the address of another one of the pairs. A scrambled chain, each thing in the inbox is an address of one of the pairs. Outbox the data for that pair and also the data in all following pairs in the chain. The chain ends when you reach a negative address. Repeat until the inbox is empty. Okay, so this is what we did last time.
Wow, that's short.
That is short.
Okay, but I didn't quite understand the topic or the problem here.
So for the 0, this one is our starting address. Mm-hmm. So we would go to 0 and output the E. And the next thing we do is we grab the 13. We take the index from 13.
Which is the S?
Which is S, so we output S. Then we go to 14, grab 3, which is C, grab the 23, which is A, grab the 10, which is P, grab the 20, which is E, and then we have a -1, which is the end of the chain.
Okay, and then we have to start in the inbox again and grab the 23.
Yeah. So this is essentially a linked list.
Okay.
We need some way of putting... We have to memorize the index though, I think. How do we do that?
Do we have to memorize the 0? If we started the chain, it doesn't matter because we also already put it out, right?
Yeah, see, if we have 0...
Yes.
So yeah, it definitely starts with grabbing from the inbox, right?
Mm-hmm.
And the next thing would be that we grab whatever's in here. Copy from
the index.
Yeah. See, we need to lay down the 0 somewhere.
So lay it down on the 2.
Okay. So copy from
the index.
The index in 2. So setting this down to 2, that will be the challenge. How do we know? Oh no, actually, yeah. We just go copy to 2. That was easy. Challenge. We managed the challenge.
Okay, with copy to 2, you put the 0 on the space 2.
So this is the index.
We don't have time for this.
I'm trying to make a heart.
Yes, but we don't have time for this.
Now it looks like Mickey Mouse. We're going to be sued. Okay, this is a heart. I don't want to hear anything about it. Okay. So this is a heart person. Right, we copy it to the heart person.
Okay.
Then we copy from the index. Yeah, and that goes to the outbox, right? And then...
Do we have to put it into the outbox? Outbox the data for that pair.
Yeah, so that's the first one is the data. Then we need to grab the next input, so we...
And also the data in all following pairs, okay.
We can just, I guess, start. Okay, so the first command was wrong.
Outbox. Yeah.
Right.
Take it from the inbox. Okay, throw that away.
Okay. Right, 23. Grab that and outbox. Next thing we need to do...
you should grab the E, right?
Oh, but it started with 23 this time.
Why?
because they always mix up the inbox, and only two values make sense at all. 0 and 23.
Okay. Why was there a mistake then?
Oh, well, it kind of worked, but we stopped after the first letter, see? Now we grab the E,
Okay.
and we outbox the E. And now the next thing we have to do is grab the thing that's in 13. So I think we have to bump the zeros, so we have 1. Right.
Yes, that's true.
So bump 0.
But we don't always have the 0 and the 1. We might sometimes have another.
Yeah, but it's always the data bit plus 1. So this is 3 plus 1 is 4, 13 plus 1 is 14. So it's always, if we picked up the letter and we bump it, we always get the next element, see?
Bump it 1 up, okay.
By 1, yeah.
Okay.
We copy from,
So you always bump the index.
yeah, so now the heart is bumped. So we're pointing to 1. Well, if we previously pointed to 0, we now would point to 1.
Mm-hmm.
So that's what we copy, right? We copy from whatever's in the index, and then we put that down to this index again. And now we should have, like, if this is 13, we bump by 1, point to 1. We grab the 13, we put it down to 13, and now we can loop back up, because we now copy from 13, which is here. Copy from 13, outbox it.
And then you bump. Okay, let's just start it and see what happens.
Okay, so we put down the 0,
Mm-hmm.
copy from the index, put it out. Get it out.
And then now we bump.
We bump,
So 1.
we copy from the 1. That's our next index.
Mm-hmm.
We copy from where it points to, bring it to the outbox. Bump it again,
14.
copy from there, get that in here, jump up, copy from 3. And when are we supposed to stop again?
When it's negative. Reaches a negative address.
Yeah, negative address, that can't be.
Do we have to compare then if it's 0 or
At some point we have to compare something.
See, we have to decide
So this
whether
is
it's
E.
negative or not. At some point.
Yeah, if we copy it here,
Mhm.
that's where we know it, right?
Yes, that's
It's
where
negative
we have
now.
to compare.
So if it's negative,
It's negative.
we have to pick the next number, right? So we go all the way up to the inbox if we reach negative. Is that right?
Yeah. Yeah. I think so.
Repeat until inbox is empty.
Yeah.
So if we pick up from the floor and it's negative, we go back up. And this is exactly 9 lines of code. This
Yeah,
is,
like the
I
other
think
one?
it's exactly like the other one. So we did way better than the last time. Okay, we didn't read the message.
Yeah.
8 or fewer, you're kidding me.
Oh. Yeah, that looks good.
Wait. 8 or fewer commands. What's the problem here? Why do we have... Oh, there's a copy too that we don't need. Yeah, this one, see? Because it's the same like up here. I reckon if we do this, that will work too. Because it doesn't matter if you copy right before we jump or right after we jump?
Yeah.
Let's see if it
Sure.
works. And now we're even better than last time. Worth it. Yeah, it looks good. I think we cracked the challenge.
Wait for it.
We did it. Yeah, and it's even the exact same amount. Okay.
Steps, yes.
So what were the words though? A, pa, ipa,
Is that a word?
A piece. So we're the apes, the small apes. Or ape. Oh, ape escape. I bet it's ape escape. Ape escape.
It's a warning.
That's the message.
It's a warning to us.
The signs were all over it. Oh, and we cracked the challenge.
Mm-hmm.
Digit Explorer. Should we get that one?
Yeah, sure.
Whew. Exploder, not Explorer. That seems simple. Nothing can go wrong
How
here.
many lines? Oh god.
32.
32. Okay.
Okay, let's maybe inspect this program first. So it just doesn't take us that long.
So grab each number from the inbox and send its digits to the outbox. For example, 1, 2, 3 becomes 1, comma, 2, comma, 3. Ah, okay.
Okay.
Now I get it.
Okay.
Wow, we had two.
We had two variants of the same thing. Yeah, one of them, this probably didn't just didn't work, right? Did it? Did it work? No, that's just wrong. Okay, so we kind of can clear that now, right?
Yeah. You sure? Yes.
Yeah, okay. So and that's the good one? Is that?
Didn't work either.
We're doing some kind of division by subtracting.
Made a temporary.
But do we have to, like, is the first thing... Three, 6. Okay.
Wait, what?
Oh, we did it! We're done! Size challenge though.
Done! Oh god.
Speed challenge.
Wow.
Speed and shit. Okay.
So this is
Okay.
a challenge.
That is a challenge.
Can we do better?
Okay.
Maybe not.
Let's see. Rubbing your hands will help. So the outbox would be 1, 2, 3. So we have to do the hundreds first, right?
Yes. Yep, yep.
Okay. I want to clear all the markings. So we grab that now. So we grab from the inbox. Inbox.
Inbox.
Let's grab from the inbox.
Do we have to put it on the floor? Or
Um,
just compare?
Can we just compare? Yeah, I think we can just let's try it. Let's just not waste anything. Let's just directly compare. We subtract 100. If we did that once though, so if it's negative now,
It's not.
that means we don't have 100,
Yeah.
right?
That the number is just 2 digits.
Yeah. And if it was positive,
Yeah. We have 3 digits.
we have to do something.
Well, we have to put out the first digit.
Well, we have to set something. We have to set a 1 somewhere.
What? Do we? Ah, and then we have
So-
to bump up.
Yeah, so if it's negative, we don't do anything. If it's positive, we actually have to store the value now.
So there is the temporary.
Copy to here. Yeah, so this is our temporary value.
Sorry.
Okay, this is not a good T. Okay, so this is our temporary. We copy to the temp. And if it's 1, we have a 0 right here. Should we just bump that? But we probably...
We
yeah.
shouldn't bump.
I don't think we need it.
Really?
Honestly, I don't think so. Let's just bump it. If we need it later, we can always create a 0. By just adding a copy statement up there or something. Let's just see if we can get away. So if we bump the 0 here, we bump the 9.
The 9, what happens then? Then it's 1.
Well, then we copy the temporary again, because we have a 1 in hand. So this, and then we subtract 11 again. Okay, and now if it's negative, that one was no 100, right? And now if it's negative, we have at the minimum 100. So this is out 100. We're negative and we're outputting the hundreds. Which means that we have the right amount on 9, which is now I. So we copy from I, and that goes to the outputs. If it is not negative, we need to make it negative by doing the same thing over again.
We're making it negative, but we are bumping up.
Yeah, we bump the I up and subtract again, so it gets lower by 100.
Okay.
Okay. And then we output the hundreds. Something's wrong about the I right now, because if you copy from I, we outbox that. We need to recreate the 0 here.
Should
So
we start and see what happens first?
Yeah, let's start.
Before
Premature optimization.
No.
Okay, we definitely have hundreds. That was the first successful one. Okay. What's the fastest way to create a 0? I feel like if we pick that up, subtract it from itself and set it down again, that's 3 statements. But we probably, 2 statements would be pick up the 0 and not enough stuff. Yeah, not enough stuff, but we output the 5. And T is 98.
98. Instead
What
of...
should it have been? Right, let's check. But 98 is correct. So if that's now 17, then we have then the tenths down here. We don't have to do anything to T. Yeah, see? Okay. That's good. I'm wondering how often do we have to reset the 0? I'm guessing once or twice. But most of them don't even have a value, so I guess let's just create a value. What do we have in hand after we put something to the... Nothing, right?
Oh, there's the first
Minus
mistake.
66. Okay, because we did not have 0, so no hundreds, we're done. Ah, but we lost the number in case of no hundreds, so we need to copy that number to... Okay, so that'll be a problem.
Do we need
This
another
jump if
temporary?
negative, we have to we have to do the temporary first. But now we would not create a temporary. That's an extra statement. Jump if negative. Before we subtract, we need to copy to t. Then we do the subtraction, and then we copy to t again. That's okay, because we need to have the number here to do the tens. Okay. Right. How do we create the 0 now? So we output it here. That's okay. Let's do the tens.
Can we put a 0 on the full floor first and then just take it every time we want to create a 0?
Yeah. Yeah.
That's
I
too
was
much.
thinking about the amount of statements that is,
Yeah.
because that is pick up the 0, set down the 0, 2 statements. And then creating a 0 is pick up the 0, put down the 0, another 2 statements. So there's 4 statements to create a 0, but we only need to create a 0 if we removed it here. So I'm wondering, like, just heuristically, maybe it's faster if we don't do that.
Maybe it's faster if we don't bump up the 0 but just leave it there
See,
and bump up another 0.
We have only 2 cases where we actually use up the 0.
Wow.
With the 67, the 0 stays a 0, so we don't have to create a 0.
Yes.
But yeah, no, they come right after. Yeah, I think you're right. I think it's just faster if we just copy a 0 for us. Zero. Okay, so we just copy the 0 and we have a 0.
Yes.
Copy from, copy to. Okay, so if we output the hundreds, we use the 0 up, so we create a new 0. And then we're up to the tens, which is kind of the same thing just for tens. We can call this one 100. And we can call this one 10. That way it shows up here. Subtract 100. Okay, so the first thing is we enter this with the 17 up here. So if we subtract 10 now, well, but we don't have anything in hand. So we copy from t. We just have to assume that we don't have anything in hand. We subtract the 10. If it's negative, then we're up to the ones. And if it's positive, then we need to do whatever was in here. I'm losing my mind.
Yes, because you're planning ahead already. Just run the program and see what's happening.
Okay.
What is happening?
So what happened here was we entered the tens, which is correct. Jump if negative, that's correct, because this does not have any hundreds. We copy from here. We subtract 10. And now we need to save the 10, so we do the same that we did in here. We copy it to t, save the value that's lower by 10 lower. Then we we bump I, that's the same thing. I just can use this algorithm up here. Copy from t again. Why are we doing that? Oh yeah, okay. Because we check another. We try to we get into this state where we checked, and then we jump up again to the check, right? Oh, that's even No, these are two different checks. These are two different checks.
Can you put a notice on the jump part so that we know why we jump or something like that?
No, I can just like do notes in between.
Okay.
But this jump is, I can, well, we can put it always there. No hundreds. There are no hundreds at all. So we just continue with the tens. And this jump is done. This is where we check if we're done with the hundreds. In that case, we output the hundreds. So now when we go to the tens, this one will be no tens. If it has no tens at all, we just jump to the ones. But if it had tens and is negative now, we're outputting tens. So we're asking ourselves if we're done. If we're not done, we have to subtract and bump again. But if we're done, actually, we output the tens. And that would be out tens. So if we're done with checking for the amount of tens, we know where we are and we output the tens. And outputting was just copy the index, outbox it, and then reset the index. Okay. So copy from index, output it, and reset the index by copying 0 and copying it to the index. Now the ones are a special case because we always have at least the ones. So I think the T now contains the 1. So we copy from T and we just outbox it. Because that's always the case. And we're in 31 statements, which is last time we used 32 statements. And I think the requirement is actually 31 statements. So if that works now, we did it.
We have 32.
Yeah, 31 is the requirement, we did it. Okay, something's wrong though.
Empty value sub 7.
Sub 7? We wanted to sub 7. Sub 10, of course. I just misclicked. That was just a regular misclick, that's alright. That's like, there's a memory type exception. And that's exactly where you kind of access something in the memory that wasn't initialized. Not enough stuff in the outbox. Oh god damn it.
No, that doesn't matter because we have to
jump.
restart and take from the inbox again.
Yeah, but now it's 32 statements.
Oh well.
It's the same thing. Maybe it's faster though. We had a lot of special checks in there, so maybe it's just executing faster.
Works with those specifics. Why?
Which one fails? It doesn't work for 7, really? Is that it? It should work for 7.
Because we output it immediately and didn't check for 0.
Wait. Ah, if 10 is 7. Okay. So if it's 704 or something, I think this is 704, right?
Why
So
704?
jump if negative. We're done. We're outputting the 7. Copy from 0. Okay, we're resetting. subtract 10. It's negative, but we handled that case actually. There are no 10s. Oh, if there are no 10s, but there were hundreds.
After a 7 there is a 2 digits number. And are we assuming it's finished? Do we start from the start? Start checking from the 100 digits?
So the thing now is that we had 100, and we don't have any 10s, so we skip the 10s, and we output the 4, which is 7-4. So that would be correct for 47. But we're missing the 0 because you say we don't have 10s, so we're not outputting anything.
So...
But we can't just output a 0.
No. So where in the code is the problem?
It's kind of the logic in here, where if there are no 10s, right? It just does not output anything. But if there are no 10s and there were hundreds, we should have done something. So...
But we are checking the hundreds first?
We're checking the hundreds first.
Yes, and then we are going for the 10.
For the tens. But these are kind of... If there are no hundreds... If there are no hundreds and no tens, then it's okay if we don't output. We actually should not output anything. But if we outputted hundreds, I think we have to duplicate this check. The first check if there are no tens. We have to do it in both cases and react differently. Because in the one case we output 100. We output the 0.
Ah, okay. Instead of
skipping it altogether.
Yeah, okay. If there are no 10s, output 0. How do we do that? Take the 0
No,
from...
we have that.
Okay.
So we copy from here. See, we are here. So we're done with the hundreds, and now we're resetting. See, it's all set up. Now we check if we have 10s.
Okay.
So we copy the 4, we subtract 10, which is negative, so we know we don't have 10s.
Okay.
But because we had 100, we should output 0.
Yeah, that's what I'm talking about now. If it's a minus, you know it's a 0, and then you grab the 0 from the floor we have prepared.
Yeah.
And then outbox it.
But there's a second case though. If there are neither hundreds nor tens,
yes,
we should not output a 0. So if the actual value was 4, we would see the same thing, but we would not have the 7 in the outbox. And we would be at the same state right now. So I think what we have to do, like up here we would decide if we output nothing for the hundreds or something for the hundreds. So this check, we have to do this check, the same check on 2 different occasions, once here and once here.
Okay.
So,
yeah, then just...
yeah, let me try it. Okay, so if we're done, we're outputting, and if not, so let me check. Yeah. So this is the check now for if there were no hundreds, then it's correct to skip if negative. And we need to do the same check if we outputted something. Tens. And this is the, wait. Tens, and this is the 100 variant. Okay, and it's the same thing. Copy from T. Copy, no, subtract the 10. If it's negative now, so theoretically, oh wait. So and then the thing is that we should not interfere with this other check. So we actually, if we're done, we jump over the thing. And if it's negative, we go kind of all the way down here. Into the output 10s, right? And then we copy from here, which is 0, outbox it, and when we jump, this is out 10s in the 100 variant. And then when we're done here, we cannot output any other 10s, so we go to the 1s. I don't know if I catched if I catched everything. But I think it's definitely fast.
Wow.
No.
But you outbox 0.
Why did we do that? Where did it come from?
0?
Yeah, jump if negative. Oh, I see it. Yeah. So if we're done with the normal thing, then we just go to the normal to the normal output 10s. Okay. No. Yeah, I crashed everything. Right. How did we get there? Oh God. Okay. So why are we here? So this is 11. Okay. Subtract 10. We're done. So we're going down here. Oh wait. That's okay. Yeah. I skipped the whole output part, but it only skipped the output part if we had to output the 0. It looks like it's working. So maybe we did it, and because we do all the jumping, this is probably faster because it skips a lot of statements if it does not need them. Ah, come on. Okay. So it does not work for 1, is that right?
In the beginning, well, it's checking for 100s. There is no 100.
Okay, so
there are
we
no 100 digits.
make a backup of the 0.
Okay.
Subtract the 100.
Yes. Negative.
Okay, so jumping all the way down
To the 10s.
to the 10s.
Yeah, it should check for
It should check for 10s, yeah.
10s.
Okay, so
So
check for 10s. Subtract,
there is no 10.
no 10.
It's jumping down. Check for the.
Oh, that actually just works.
Okay.
Oh, it wasn't that. Okay,
So the next one.
that's wrong. Was that?
So he jumped up.
Oh, we made another backup of... Wait, we don't have to do that. Okay, so I'm sorry. But we don't have to do that. Just run through the backup once.
But was that a problem? No.
It's entirely possible. No, probably not. But I changed something, so we could have a new problem now. Okay, she's screaming at us again. Okay. Does it fail for 190?
Maybe not that fast, so we can see where that problem comes in there.
Well, it will crash.
At the end.
Yeah, and then we can
Somewhere-
step back from there. That's what I'm thinking. Because I don't know, maybe it's for 206 the problem, and then we'll be stuck here forever. So
Now it's
206. We didn't output the 0 here.
206.
Why did it fail?
Did we grab the 0 to output it?
So now we're doing the last hundreds. Subtract 100. Okay, we're done. We're outputting the hundreds. We're resetting the 0. And now this is exactly the check that we just built in. So we copy that. We check it if it has zeros, which it doesn't.
Now you grab the 0 from the 0 we prepared.
Yeah, so we're jumping to the point where we
didn't
should do that.
No, we haven't written it.
No, here, see?
Copy 2.
Copy.
Okay. Copy 2.
Wait.
Next.
And I'm not sure what this does. What is this? This is output 0. It should jump down here.
What does this do?
That one's, so we wanted to output the 0.
Okay.
And where's this jump coming from? If negative. Wait, why wasn't it negative?
It was.
No, it jumped. No, wait. Now I messed up. No, this one stays up here. It jumps before it checks if it's negative. That's the problem. I jump in any case. If I wrote it like that, which is jump, and then it's gone. It does not check for negative.
We did have a negative in hand.
Yeah, right. But the way I've written the statement, I've written it like that. So which is now you have a negative, and in any case you jump. We don't check jump if negative, and the jump address from this one is just continue normally. But we want the jump address of this one, which is printed 0.
Yeah.
Yeah, I think that was it. It's a good thing we have all these test cases and that they can verify whether or not we're right or not. It's way easier to work with test cases.
Okay, let's slow down.
Yeah, sure. Is that the case where it happens? No, no, it's not. The case where it happens is not in there. I think, right? Or was it? Oh, that was 102. That was the case. Yeah, we did it.
Yeah, that's what I wanted to see.
Okay. Yay!
It's working.
We did it. We have a lot of statements, so we did not crack the size challenge.
Speed, not either.
Really? Okay, but I'm happy.
Yeah.
Yeah,
I
we
need a
did
break.
it. Yeah, me too. Also coffee. So that was number 37. We did that first. It was very quick, and then we did 38.
That's it.
Yeah, that was
we
the
haven't
digit,
done, okay. Digit exploder.
right? Yeah. That's the digit. Scavenger chain was the one where we jumped the
Yeah.
data pointer pairs.
Okay.
Digit exploder. All right. 3
So-
more to go, and then the rewarding end video. So
See you guys in the next video.
stay tuned. See you soon. Bye.